So we will solve recitation problem for chapter 6. And of course, the quiz will come out of these recitation problems, okay, of chapter 5 and chapter 6 I already sent you. Of course, I will change the numbers and I'll change the situation. Good. But those who understand what's going on and how to solve these problems, you will not have difficulty in the major exam, okay? Because these problems are more difficult than the exam problem. Again, don't underestimate a problem, okay? In the exam, you will have, let's say, 20 questions. Let's say 15 are, okay, average problems. 3 of them or 2 of them will be more than average, and you will have 2 difficult problems. Not difficult, but let's say multiple steps. So don't underestimate any problem, no matter how easy it is, okay? Good. Because all of them will bring you 1 point, and 1 point is not negligible. It's like when you are doing martial art, you know, these professional martial artists, fighters, they respect any opponents, okay? Even if they know that, you know, I can win easily. Anyway, now let's go to this one and be like the German national team. These are professional football players. They can beat you 10-0, they will beat you 10-0. So, yes, okay, good. Now let's solve this problem, which is very simple. So we have a car that moves on a level horizontal road in a circle of radius 40 meters. So the coefficient of static friction between the tires and road is 0.5. What is the maximum speed with which this car can round this curve without sliding? So this is kind of simple. You know the formula. Mu s multiplied by g is v squared over r. Now, in some problems, I will give you v and r, and I will ask you mu s. In some problems, like this problem, I will give you mu s and r. I will ask you what is a v max without sliding, etc., etc. All what you need to know is you need to put everything in SI units. Okay? So this g is in meter per second. So if I give you a speed in kilometers per hour, you put it in meter per second. If I give you a radius in kilometers, you put it in meters. So you put everything in SI unit. So here I gave you mu s, I gave you r, so I'm asking you v. V max is just square root of mu s g r. Okay, so I just get v square is mu s r g, and then I take the root and I do my calculation. Now, if you don't remember the formula, let's derive it. Okay, because here we have a circle. So let's say this is a circle, this is the center of the circle. Let me look at this view here. This is a top view. So in the top view, what do I have? Of course, my velocity is always tangent to the circle. Okay, the circle looks bad, but you understand what I mean. So this is a velocity. The acceleration is always centripetal, AC. And here you have the frictional force between the tire and the road playing the role of the centripetal force. Okay? The centripetal acceleration is due to the centripetal force, which is a frictional force. And I told you that because we have a centripetal force, but we feel a centrifugal force. We feel like we are going away in this direction. Okay? But centrifugal force, let me call it F centrifugal, is opposite and equal to the centripetal force, Fc. And in order to describe the centrifugal force, I will need to say that it's rotating, it's a non-inertial reference frame, it's a long story. So I will not talk about centrifugal force. I will just talk about centripetal force. And this is a force that prevents you from sliding away. This is a force of friction between the tire and the road. Okay, so since this is a top view, of course, here the weight is pointing downward. Okay, this is mg downward, and you have the normal force pointing towards you upward, right? Good. Now here's the centripetal force here is just m AC, which is mv squared over r. And here, by the way, is equal to Fs, static friction, okay, between the tires and the road. And this should be equal to the maximum, smaller than the maximum static friction, Fs max. Why? Because if this is bigger than the maximum static friction, I will slide away. Okay, so it should be smaller than the maximum static friction. So the maximum speed is such that mv squared over r is equal at max to the maximum static friction, which is mu s Fn. But you know that Fn is just mg, right? Because it's flat here. So it will be mu s mg. I simplify by m, and I end up with mu s g is v squared over r. Okay, and this is a famous relationship that we will be using. It's not in your formula sheet. Write it down. It's not in the formula sheet. So if you don't remember it in the exam, redo your free body diagram, and then you check the physics, and you will end up with this. Okay, so better remember it. You will gain, let's say, 1 or 2 minutes. So let me do it here. So I get V max is 14 meters per second. Okay, good. Now let me go to the next step. So here, what did I have? I have a curved, I had a flat, curved road with friction. And I solve it, I get this. Now let me go to the next one, which is a banked or tilted curved road without friction. So let's read the question. At what angle should the circular roadway of radius 50 be banked to allow cars to negotiate the curve without slipping at a maximum speed of 12 meters per second? Ignore friction. I will always ignore friction, not always, but in this case, I will neglect friction. Why? Because as a civil engineer, when I design this road, I look at the worst case scenario. The worst case scenario is it's raining, or it's, you have ice, snowing, so the friction is negligible. So even if friction is negligible and at this maximum speed, what should be the angle that will prevent my car from sliding at this maximum speed? So here again, you know the formula, it's easy for you. Tangent theta is v squared over rg. So write down this formula. We already derived it in class, but well, I will re-derive it. So if you remember this formula, things are easy for you. Okay, you just apply the formula, and it's not in your formula sheet. So the first formula to remember is mu s is v squared over rg, which is in the previous case. Okay, in this case, you have tangent theta is v squared over rg. So that means theta is just tan inverse of v squared, which is 12 squared, divided by r, which is 50, multiplied by g, which is 9.8, and you get your angle theta, which is 16.3 degrees. Problem solved. Bye-bye. Okay. Now, how to get this formula? If you don't remember this formula, it's fine. I ask you to remember it, but in case you don't listen to me, it's fine. Now do the free body diagram. So I want you also to remember this formula. It's not in your formula sheet. Now you do the free body diagram. Okay, let's look at a side view. This is my side view here. This is the angle theta. This is my object. It has a weight. This is my car, basically. The weight here, downward in magnitude is mg. I will have a normal force here. So how will my normal force look like? Of course, it's normal to the inclined plane. Okay. Now I will have acceleration, and the acceleration is centripetal. The acceleration actually is horizontal. It's looking toward the center. So the acceleration is like this, AC. Okay, good. Now always choose your XY axis such that your acceleration is purely along one axis, okay, which is the X axis. So here I know that the acceleration is centripetal. So better for me to choose an X axis, which is the horizontal here. x. And then I'll choose my y-axis, which is a vertical here, y. Why I'm doing this? Because I know that the acceleration is centripetal. Acceleration will be AC along x and 0 along y. And this will make my life easier. Okay. You remember, in an inclined plane, in previous chapter, this is my object. It can slide down. The acceleration is along the incline. That's why I was telling you to choose this as my x-axis and this as my y-axis, such that now the acceleration here will be purely along x, and along y it will be 0. Okay. Here, don't do that. Don't choose this as my x-axis and this as my y-axis. Otherwise, this acceleration will have two components, one along x and one along y, and that will not make my life easier. So always choose your x and y such that your acceleration is purely along one axis. Good? Okay, and this you will study it in linear algebra. You have matrices and vectors. You can have eigenvalues and eigenvectors such that your matrix will be purely diagonal and you will not have off-diagonal terms, and this will make your life easier. But of course, your physics will be the same. No matter which axis you take, you can even take axes that are not orthonormal, that are not perpendicular to each other. But you know, you will make your life more difficult. Okay. So here, my x-axis is purely along is this, and my y-axis is this. Now let me apply Newton's second law. Here I don't have friction, right? So I ignore friction. So my Newton's second law on my car would be normal force plus gravitational force is equal to mass of the car multiplied by acceleration. Now let me project it along x. Along x, what is the normal force along x? The normal force along x is this component here. Of course, if this is theta, the same theta is coming back here, and the same theta is coming back here. So the normal force along x is just this component here along x. It will be what? Fn cosine or sine? What do you think?
Sine.
Sine theta. Thank you very much. Yes. And the gravitational force along x is of course 0, because the gravitational force is purely along y. And this is equal to ma, but a is a centripetal acceleration along x, which is v squared over r. Now along the y-axis, Fn along the y, of course, it will be this component. So it will be Fn plus, of course, Fn cosine theta. Now gravitational force along y is minus mg. And this is equal to what? 0, because there is no acceleration along y. The car is not jumping along y. Of course, the acceleration is purely centripetal, purely along x. This is 0. So basically, I just get Fn cosine theta is equal to mg. So this is along the y. Now let me take the ratio x divided by y. The x component, the x equation here divided by the y equation. So you see the Fn will simplify, and I will have sine divided by cosine, which is tangent theta. And here I will have mv squared over r divided by mg, the m will go away, and then I will have just v squared over rg, okay? Which is the formula that I used from the beginning, okay? So you can do this in less than 2 minutes, and you get your right answer, and that's it. If you remember the formula, you just plug in and you get your answer. And you get, of course, an angle of 16.3 degrees. Now, let me make it now more difficult and look at the most general problem. Again, here, this Vmax here is a V design of my road, my banked road. So when I design the bank road, I look at the worst case scenario, which is there is no friction. Okay. A slippery road, you know, icy, friction is equal to 0, but still, if I respect the maximum speed here, I will not slide and I will not slip. I will not have an accident, okay, if I respect the maximum speed. Now let's look at the most general case. So the most general case actually is a banked, curved road with friction now. Okay. basically theta is different from 0 and mu s is different from 0. So basically this is the first two problems combined in one. It's a circular, it's banked, but also I have friction. So let's read it carefully. Always read the question carefully. Okay? Because we are in physics, we are not in maths. I can change the word, it can change the entire scenario. So read carefully and you solve. Now, here I have a banked circular highway curve is designed for a traffic moving at 60 kilometers per hour. So this is my V design. This is my V max. And again, V design, V max correspond to what? Friction is equal to 0, worst case scenario. And I gave you the radius of 200 meters. So here I'm giving you actually the angle theta. So you know that tangent theta is equal to V design or V max squared divided by RG. So that means theta is just tan inverse of V square divided by RG. Of course, V square, V. So here I'm talking about V design, V max, okay, which corresponds to the previous one, which is 12 meters per second. But here, of course, I have to put it in SI unit. It's 60 kilometers per hour. So basically in meters per second, it's just 60 divided by 3.6. Okay, you multiply by 1,000, divide by 3,600. So basically you just divide by 3.6. So it will give you 17 meter per second square divided by R, which is 200, multiplied by G, which is 9.8. Be careful, okay? Change everything in SI units, okay? Last semester, I gave them a V in mile per hours, okay? And student just took it and plug it like this. This G is in meter per second, so put everything in meter per second. So you do this, you get an angle of 8 degrees. So this is the design of your banked road. Now, let's keep reading. Traffic is now moving along the highway at 40 kilometers per hour on a rainy day. So you see that the velocity, the speed that I have, sorry, is smaller than the V max, the V design. Okay, V max is V design, which is 60. So the speed, which is 40 here, kilometers per hour, is smaller than the V design. So what does it mean? If I go slower than the V design, I have a tendency to slide downward. Let me show you that. So this is my side view. Okay, this is my car. The weight is downward. The normal force is normal here. Okay, the acceleration is centripetal, is horizontal here. And of course, this is my angle theta. Okay. Of course, the same angle theta is coming back here. Of course, I will choose this as my x-axis because I want the acceleration to be purely along x. Now, this is my y-axis here. So of course, this same angle theta is coming here. Now here I need a friction. Otherwise, I will slide. So here V is smaller than V max. So that means that I'm smaller, I'm going at a lower pace than the maximum speed. So I will have a tendency to slide downward, down the incline, because I'm going at a slower speed. And then I need friction to keep me on track. So the friction force will be up here, Fs. If my speed was bigger than V max, I will have a tendency to slide up the incline, and the friction force will be downward. Okay. So depending on the speed, if I am a careful driver or not careful driver, or let's say I follow the rules. This is like the Germans, they follow the rules. This is a Vmax, I go at the Vmax. So if you go at the Vmax, of course, the friction is not necessary. But if you go slower than the V design, I will have a tendency to slide down the incline, and friction is needed to keep me upward. If I'm going at a speed which is bigger than Vmax, I will have a tendency to slide up, and friction will be downward to keep me from sliding up. So here friction is needed to keep me from sliding down. So this is why the question is, what is the minimum coefficient of static friction between the tire and the road that will allow the car to take the turn without sliding off the road. Here by sliding off the road, I mean sliding down the inclined plane. If the V here was bigger, sliding off will be sliding up the inclined plane. Okay, so this is my acceleration here. Of course, the acceleration is purely along X and 0 along Y. And here I have frictional force here. Again, frictional force. This is my X-axis, this is my Y-axis. So the frictional force is doing an angle theta because this is a correspondent angle. This is theta and theta is coming back here. Now, let me do it now. I will use Newton's second law. I have normal force plus gravitational force plus now frictional force. Now it's not neglected, is equal to MA. This is my Newton's second law applied to the car. Now let me project it along X-axis. Fn along X, of course, this is what I have. This is Fn along X. It will be plus Fn sine theta. What is Fg along X is 0. What is Fs along X? So this is what I need here. So it will be plus Fs cosine theta. And this is equal to MAX. But AX is a centripetal acceleration. So it will be V squared over R. Okay. And along X here, this is what I have. Now here, of course, if I am not sliding, this Fs should be at most equal to the maximum static friction. So here I will say that Fs is equal to Fs max, because otherwise I will slide if Fs is bigger. Okay. So basically, I have to, you know, that's here I will say that Fs is equal to the maximum static friction. And you know that the maximum static friction is mu s Fn. By the way, here, what is Fn? Fn, I apply Newton's second law along the y direction. If I apply Newton's second law, okay, let me do it this way. I will not apply Newton's second law along the y direction here. Let me just keep it as this. Okay, I will apply it later. I will just say that Fs is mu s, Fs is Fs max mu s Fn. So that means I will have Fn. I can put Fn in a common factor. I'll have sine theta. And here Fs, I will replace it by mu s Fn. And I put Fn outward. So I'll have mu s cosine theta. And this is equal to m v squared over r. So this is my first equation. And this is coming from Newton's second law along the x-axis. Now let me apply Newton's second law along the y-axis. I just take this gentleman, I project along x, and I project along y. Along y, I will have plus Fn cosine theta, because this is now a cosine. This is what I need. What is a gravitational force along y? Is minus mg. It's purely downward. Now, what is the Fs along y? Fs along y is this. So it will be what? Plus Fs sine or cosine? Sine theta. And this is equal to MAY. AY is 0, so this is equal to 0. Okay. So let me take the weight and put it on the right-hand side. So I will have here plus is equal to plus mg. So here I will have Fn cosine theta. And here I will have Fs. Fs, I will replace it by mu s Fn. Now let me put the Fn out of the as a common factor. So I'll have Fn cosine theta, right? Plus mu s sine theta. And this is equal to mg. And this is my second equation along the y. So now let me take the ratio x divided by y. Basically, this is x equation, this is the y equation. You see the Fn goes away, and I will end up with sine theta plus mu s cosine theta divided by cosine theta. Sorry, I have a mistake here. Yes, so the mistake is here. Here it's a minus. You should tell me, guys. Are you following?
Yes.
Human, I make mistakes. So if I make mistake, it's a typo, you tell me. This is a minus because this is x. So this Fsx is negative. Okay, so this is a minus here. So this is a minus here. Okay. This component of the frictional force is negative along x. Okay, plus mu s sine theta. This is equal to, now here, of course here, because I take the ratios, the Fn is simplifying. Along the right hand side, the m will simplify. And you will have v square over rg. Okay, so this is it. Now I know theta from the first two lines. So I know sine theta, I know cosine theta. The only unknown is mu s. I know v, because v now is 40. So in meters per second, it will be 40 divided by 3.6 meters per second. I know r is 200, I know g 9.8. So you do it and you find that mu s is just 0.078. Okay, so write down this formula here. And again, this is true because what? Because I have a speed which is smaller than the design speed. Okay, let me choose this. Okay. If I had a speed v which is bigger than the design speed v max, I will have the same thing, but instead the friction will be downward here. Because now my v is bigger than the design speed, I will have a tendency to slide up, and the friction force will oppose the tendency to slide, so it will be downward. So what does it mean? It means that I will have the same type of equation, but here instead of having minus, I will have a plus. And here instead of having a plus, I will have a minus. I'm just changing the sign of the Fs. Okay, Fs was like this before, but now because v is bigger than v max, Fs is like this. Okay, so write it down and redo it. Okay, now this is a general case, so that means I should get the two simple cases. What are the two simple cases? The first case was a flat curved road with friction. This is problem number one that we solved. So that means theta is equal to 0. So when theta is equal to 0, the sine theta is equal to 0. Now sine theta is equal to 0 means I will neglect this. This is 0 and this is 0. So I will end up with basically mu s is just v square over rg, as we already know. Okay, because this will be 0 and this will be 0. So here I will have a plus, of course, plus mu s. Why? Because actually, when I'm on a flat road, the frictional force is toward the centripetal force. Okay? So you will have mu s is v square over rg, as we already demonstrated. Now, what is the second case? The second case was a banked curve, now without friction. Without friction. So in a bank curve without friction, what do I have? Of course, mu s is 0 now. So that means I get rid of the frictional part. And I will just end up with sine theta divided by cosine theta, which is tangent theta, is just v square over rg. Okay. So this formula here is more general, okay? But the most important thing is how to get the formula, how to go from one to one. Okay. Good. And here, of course, Fn is just mg divided by cosine theta plus mu s sine theta. Once I find mu s, now I can find what is Fn. I just use the Newton's second law along the y-axis, and then I just do it, and I get it. Is it clear?
Yes.
Okay. By the way, I did not need to do all this because you look here, how I did it in the slides is different. Here, of course, here my acceleration. Okay, let me just erase this. Okay, let me erase all the ink here. So the solution is already given, by the way. Okay, as usual, in all the recitation problem I'm giving you, I give you the solution. And you look here. Here, the only difference is, well, I did not choose carefully my x and y axis. Now my acceleration has an x component and a y component. But if you do it, the physics will be the same. I will get the same final answer. But I will go for more steps because now the acceleration is not 0 along one axis. Okay, because here I chose x to be downhill and y, which is on the incline. Okay, so basically your acceleration will have two components. Okay, so let's go to this problem here. If you don't have any other questions, somebody has A+ problem. Yes, Hussam, that's an A+ problem. Yes, that's correct. Okay. And again, if you are able to solve an A+ problem, that's very good. Okay. Now, but don't underestimate a C problem or a D problem or, you know, an F problem, because at the exam, all the problems have equal dignity. All of them, say, count for 1 point. Okay. So don't go for it, solve it. You know, definitely in the major exam, the question will be simpler than these problems. Okay. Okay, so let's look at this problem here, which is interesting as well. So I have two blocks. They are released from rest and are observed to have an acceleration of 1.5 meters per second. Okay. What is the magnitude of the frictional force on the block that slides horizontally? Basically, this table is not frictionless, so it has friction. Okay. So all what I need to do is I know that the magnitude of the acceleration for the M object is equal to the magnitude of the acceleration of the object that has a mass of 2m, and it's equal to 1.5 meters per second square. Of course, this object, M object, is moving toward the right, so the acceleration is moving toward this way, and this acceleration is downward here. But in magnitude, it's 1.5, both of them. Now, let me do a free body diagram. Of course, this one, here you will have a tension on this object, and here you will have a frictional force, which is opposing the motion because the table is rough. So this is tension T, okay? And of course, here you will have the weight, mg. It will be equal to Fn because you don't have acceleration along y. So Fn is just equal to capital Mg. Now, if I do free body diagram on this 2m block, you will have what? The weight, which is 2m multiplied by g, and then you will have the tension, T. Again, this rope is the same. The tension here in magnitude is equal to the tension here. Why? Because this pulley is massless. I don't have to apply Newton's second law on the pulley. Later in chapter 10, now we will learn what is Newton's second law for this pulley. Now the tension here will be different from the tension here. But for now, the tension in the same chord is the same because the pulley is massless, frictionless. Okay. So now let me apply Newton's second law on this block along the x-axis, the direction of motion here. This is the x-axis. So you will have plus T minus Fk is equal to plus Ma. Okay. So I have two unknowns, T and Fk. Now I will apply Newton's second law on the second block along the y direction here. So I will have plus T minus Fg, which is 2mg, is equal to minus, because this acceleration is downward, minus 2ma. So I have two equations, two unknowns. So you know how to solve a system of two equations, two unknown. Substitution, addition, or Cramer method. So here, let me just do kind of addition. Let me do 2 minus 1. I will take the second equation minus the first equation. So I'm getting rid of the t. T minus t will be 0. So I will have basically Fk minus 2mg is equal to minus 2a minus ma, which is minus 3ma. So that means Fk is just 2mg minus 3ma. And you put the numbers. I know m is 1.4. I know a, which is 1.5. And I will get a frictional force of 21 Newton. Okay. So here I did separately Newton's second law on this object, Newton's second law on this object, and then I solve my system. Now let me do it a more straightforward way. I will define a system. So of course, if you solve chapter 5, you know now the system will be m plus 2m plus the string or the rope. So now the acceleration of the system, as you know, in magnitude, will be acceleration of m, of course, which is acceleration of 2m, of course, which is 1.5 meters per second square. But you know that for the system now, I can apply Newton's second law. What is the magnitude of the acceleration of the system? The net external forces along the motion divided by total mass. So basically A, which is 1.5, is equal, what is the net external forces along the motion? Let's study the motion first. So the motion here, let me draw it, you will see, is very simple. It's just this motion. This one is moving toward the right and this one is moving downward. So this is a plus motion. So which force is dragging the motion? It's this weight of the second mass. So you will have the weight of the second mass, which is plus 2mg. Now, which force is opposing the motion? Of course, the frictional force is opposing the motion. It's an external force. So you'll have minus Fk is equal to total mass, which is divided by total mass, m plus 2m, which is basically 3m. And this is equal to A. So basically you will have Fk now is just equal to what? 2mg minus 3m multiplied by A, which gives you the same answer. And it will give you 21 Newton. Okay. Two ways. The long way, the short way, always lead to Makkah. And you pray for me when you go for Umrah. Okay, so 21 Newton. Now let me go to this problem here. Any question? Clear? Okay. So this is also an A+ problem. So read the problem carefully and then we will solve it. So this is A+, or let's say A++. Okay. Like C++. Or Python. This is a Python problem. Anyway, so we have figure 7 that shows a box. I did not give you the mass of the box. You know that the mass will be simplifying everywhere. Okay, so let me just call it M. So with a constant speed of 5 meters per second. So down a rough slope with an angle of 8 degrees. So this angle theta is 8 degrees. The same angle here is 8 degrees. So we reach the bottom of the slope with constant speed. So I know that when it reaches here, it reaches with the same speed because it's constant, 5 meters per second. And then slide up a second identical slope. Okay. Slows down and stops. So it goes up, 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 up. And let's say here it will stop. Final speed. V final is 0. Now you know work kinetic energy theorem, by the way. So this you can solve it using work kinetic energy theorem, but I will not do that because we did not finish yet chapter 7. I will use acceleration, of course. Okay. So the question is how far, because I gave you initial speed, initial kinetic energy, and final kinetic energy. You can use work kinetic energy theorem, but later. Okay. How far up the second incline, up the second slope, will the box move before coming to rest? Basically, I want this distance here. Let me call it D, which is delta X, let's say. Assume that the coefficient of kinetic friction is the same for both slope. Okay. I could have not say this because I said identical slope. Identical slope means, of course, this angle theta is the same, but both slope are rough, and the mu k here is equal to the mu k here. Okay, so I could have forgotten about this last sentence here. Okay, now let's solve it. Okay, if you know the formulas, well, I don't suggest knowing the formulas. I always suggest students to do things, okay, step by step, and then you realize things. But let me solve it, and then I will give you some formulas that I want you to remember. No. Good. So first, let me find mu k. Once I get mu k, life will be easy for me. Okay. And then here, this is a distance that I want. Of course, if I get the acceleration here in this, because the acceleration will be constant, what is the acceleration here? I can get what is the distance. Because you know that V final square is equal to V initial square. I'm talking about this in this slope, right? V final is 0 is equal to V initial square plus 2 times acceleration multiplied by delta x or d. Let me call it delta x here. Okay. Okay. So that means if I get the acceleration first, the delta x is easy. So delta x will be just V final square minus V initial square divided by 2 times the acceleration. Okay. Since I want a distance, let me take the absolute value to make sure that everything is just fine. Okay, so it will be minus 0 minus 5 square divided by 2a. Now first I need to get a. Okay, now those who know the formulas, you get a directly. You can get it easily. But let me do it step by step. So first let's get the a acceleration in this slope here. Okay, so in this slope, this is my angle theta, and this is my object. So here the object is moving up. Okay, velocity is up, and then eventually I will stop. So what is my weight? Vertical downward. This is Fg. Of course, I will have a normal force, Fn. Of course, always Fn is normal to the surface. So what is the direction of frictional force in this part here? The frictional force is opposing the motion, is opposing this tendency to slide. So I'm sliding up, the frictional force is down here. Do you agree with me?
Yes.
Fk.
Yes.
So if I apply Newton's second law, I will have Fn plus Fk plus Fg is equal to ma. Now let me do it along the x-axis. So by x-axis, I will choose this. And by y-axis, I will choose this. Of course, theta is coming back here. So Fn along x-axis is 0. Fk along x-axis is positive because it will be plus Fk. Now Fg along x-axis will be positive because you see Fg is along the positive x-axis. So it will be plus mg sine theta. And this will be equal to ma because the acceleration is purely along x-axis. Okay. So you know that Fk is equal to what? Is mu k Fn. But Fn, of course, if I use Newton's second law along the y-axis, I will have basically Fn minus mg cosine theta. Fk is 0 basically along y because it's purely along x, and this is equal to 0. So Fn is mg cosine theta. So Fk here, which is mu k Fn, is just mu k mg cosine theta plus mg sine theta is equal to ma. So let me simplify by m, and I get my a, which will be just g sine theta plus mu kg cosine theta. So this is the acceleration of my object when it's sliding up the inclined plane. And you see this acceleration is big. And you see what is important in this acceleration is the gravitational force and the frictional force along the direction of motion are in the same direction. Both of them are opposing the motion here. So they are downward here. Okay. The g sine theta part and the mu k cosine theta part are both downward. Okay. Good. So this is the acceleration. Once I get this acceleration, I plug it here and I find my thing. Now, the problem is I know everything. I know g, I know mu k. No, I know theta, but I don't know mu k. Now, how to find mu k? Let me go to the first part. The first part, I have constant velocity, means acceleration is equal to 0. Mean acceleration along x is equal to 0, acceleration along y is equal to 0. Here I can use a formula as well, but I will not use a formula. Let me just plot it. So this is now the first part here. Okay, let me put it here because otherwise it will be too. So I want you to do this, okay? So of course, this is my theta, this is my object, this is the weight, mg, this is the normal force here, Fn. Now, of course, I'm going downward here. The frictional force will be opposite, Fk, opposing this motion. So if I apply Newton's second law, I will have Fn plus Fk plus Fg, sorry, plus Fk is equal to ma. But a is 0, so is equal to 0. Now let me project along x. What will be my x? My x is this here, because the acceleration is purely along x, and this is my y. So along x, I will have plus Fk minus mg sine theta is equal to 0. And along y, I will have as usual, I will have just Fn is equal to mg cosine theta. Now let me use this here, Fk minus mg cosine theta. You know that Fk is mu k. Okay, now it's becoming messy now. So Fk is mu k Fn. So it will be mu k mg cosine theta. So now let me plug it here. So I'll have mu k mg cosine theta minus mg sine theta is equal to 0. So basically, I'm just telling you that Fk is equal to the x component of the weight because there is no acceleration along that direction. So you see here, m goes away. So, and I find that g also goes away. I find that mu k is just tangent theta. So basically mu k is tangent of 8 degrees. Now, once I get mu k, I plug it here. I get the magnitude of this acceleration, and then I plug it here, and then I get my distance, which is 4.6 meters. Okay? Is it clear? Not really.
Yes, it's clear actually.
Okay, now let me give you now the formulas. Now, what I want you to remember is this. If I'm going up an inclined plane and I have friction, I'm going up the inclined plane. So V is like this. So I have an inclined plane now with friction, mu k. So what is the acceleration of the block? Because the acceleration of the block will have a component which is minus g sine theta. This is coming from the weight. And this you can do it using Newton's second law along the inclined plane. Now, here also you will have, because it's going up, the frictional force will help the weight slow down the object. So you will also have minus mu k g cosine theta. So my object is here, it has a mass m. So this is the acceleration. And of course, in absolute value, it will be plus plus. And that happened when I had this here. So in absolute value, where is it? Where is it? Where is it? Where is it? Where is my acceleration? Yes, it's here. Okay. It's plus plus. So this is, write down this. Second thing, if I'm going now down an inclined plane, so the velocity is down here, this angle is theta, and I have friction, and I have my object here, what is the acceleration? Of course, you will have the weight pulling down, basically minus g sine theta. Minus is because I'm taking the positive x to go up. So everything which is down, because here you will have Fk here, and you will have basically Fgx here. Here now, it's going down, Fk will be opposite here, but Fgx will be here, okay? So this is Fk here. So you'll have minus g sine theta from the weight, but the friction will be opposing. So you'll have plus mu k g cosine theta. Okay. So here it's a plus, okay, because the weight is pulling down, but the frictional force is opposing. Here, both of them are in the same direction because I'm moving up. So gravitational force and frictional force, or gravitational force along x and frictional force are pulling down. Okay, so now I want to solve this problem and this problem for the rest of the time. We have 1 minute. Oh, it's already time. So what I want you to do is to solve this problem and this problem. at home. Okay? This was a quiz. I used to give this difficult quiz to my students, and students used to have full marks. And I believe if I give you this, you will have full marks as well. So I will discuss them tomorrow, inshallah, because these are very important and I want to discuss them in class. And then you are ready for the quiz, inshallah. So thank you very much and see you tomorrow. Assalamu alaikum wa rahmatullah.
Thank you, Doctor. See you.
See you.
Thank you, Doctor. See you tomorrow, inshallah.
Thank you, Husam. Have a good day.